Hello my dear students and welcome back to the surface chemistry chapter. So students, in the previous session we were discussing about the electrical properties of the colloids. In that, when we were discussing the electrical properties of colloids, the last part that we were discussing about the formation of a double layer on the sole particle or colloidal particle. On the surface of the colloidal particle, actually there are two layers of opposite charge are formed. How two oppositely charged layers are formed? We know that the colloidal or the dispersed phase particle, this is before, see, one thing I want to make it clear, that before any adsorption of a charge on their surface, dispersed phase particles will be there. Before they become colloid, they are called as a dispersed phase particle. To become colloidal particle, they have to adsorb some charge on their surface. Okay, so first they have to adsorb one charge. Okay, so here the sole particle or the dispersed phase particle, first now, which is silver iodide here. Now, so this silver iodide can adsorb either positive charge or negative charge. If the positive charge has to come on this, then AgI has to adsorb Ag plus on its surface. Okay, and if AgI has to be negatively charged colloid, then it has to adsorb negatively charged iodide ions. Okay, in this case, now the silver iodide has adsorbed iodide atoms, iodide ions on its surface. So the charge is negative charge. So this first layer formation, first layer is called as fixed layer. That you can, I hope you can, you are able to see it. Okay, so the fixed layer is nothing but the charge adsorbed by the dispersed phase particles. Okay, now once the formation of first layer takes place, this will attract the counter ions. Counter ions means oppositely charged ions again. So now iodide ions are negatively charged, therefore these will attract the positively charged potassium ions. So they will, there is formation of, again there is a formation of second layer. Okay, now this second layer is called as diffused layer. It is called as diffused layer. Okay, so now see, this first layer, which is negatively charged, it has got certain potential in it. Okay, and the second diffused layer which is formed, it has its own potential, isn't it? Now see what we the combination of double layers of two opposite charges around the dispersed phase particle is called Helmholtz, is called as Helmholtz electrical double layer. Then the potential difference between the two layers of opposite charges is called as zeta potential. This is very important. It is called as zeta potential or electrokinetic potential. Okay, so the potential difference between fixed layer and diffused layer is called as zeta potential. Now I want to add one more point here. For a colloidal particle, for any colloid, okay, stability depends on zeta potential. Okay, if the zeta potential value is high, its stability will be high. If zeta potential value is less, then its stability is less. Why? I'll tell you why. See, now the potential difference between these two layers is more. If it is more, then this will be more stable. Okay, means this diffused layer or the second layer is there, no, that will protect the other ions to form on this. Okay, third layer formation agudilla. Suppose iga zeta potential kadime adanti kodre, the value of zeta potential is less, andre the potential difference between these two layers is less, then what will happen? These two layers will combine, andre potassium will react with the iodide and they will become potassium iodide, so they will removed. So the double layer present on the colloidal particle is removed when the potential difference between these two is very less. When the zeta potential value is very less, then there is no formation of the double layer. So when there is no formation of a double layer on the colloidal particle, what will happen? These dispersed phase particles, when they come closer with another dispersed phase particle, they may aggregate, they may get associated. Okay, they may get associated and they may form precipitate, isn't it? So we know that the stability of the colloidal particles depends on the charge of the colloidal particle, means whether they are positive charge or negative charge. Okay, so the charge on the colloidal particles is the important factor for the stability. Okay, then moving on next. Next we have to study one concept called as electrophoresis, which is very important for even 1 marks or for 2 marks. Okay, so 1 marks they will ask you what is electrophoresis, or for 2 marks they will ask you to explain what is meant by electrophoresis. So let us see what is meant by electrophoresis. Okay, now we know that colloidal particles are either negatively charged or they are positively charged. So how do we prove or how do we confirm that the colloidal particles are having some charge? So we need an experiment, and that experiment name is electrophoresis. The experiment name is electrophoresis. So now electrophoresis, the experiment consists of one equipment, and that equipment is U-shaped tube. This is your equipment, which is U-shaped tube will be there, and inside this tube we have taken the colloidal solution. We have taken the colloidal solution, or simply I can say the sol. Okay, so colloidal solution I have taken. Okay, and in this U tube what I have inserted the platinum electrodes. I have inserted platinum electrodes in the 2 limbs. Okay, then when I pass electricity through this colloidal solution, what will happen? No, it's just like electrolysis. We know what will happen in electrolysis. In electrolysis we have taken an electrolyte. Okay, and we have immersed 2 electrodes in that electrolyte, and when we pass when we pass the electric current, now the electrolytes is having 2 charges, so both the charges will move towards the oppositely charged electrodes, isn't it? The same thing will happen. Now for example, I have taken here arsenious sulfide, which is negatively charged. Okay, so on passing electric current, as the arsenious sulfide is negatively charged, it will move towards the positively charged electrode. Okay, so positively charged electrode towards the anode it will move. Okay, so here the arsenious sulfide molecules, they will get precipitated. Now what will happen in electrolysis? We know that when an oppositely charged ion moved, when an ion of certain charge moved towards a electrode, there it loses its charge. ಅಂದ್ರೆ ಈಗ ಇಲ್ಲಿ arsenious sulfide ಅದ which is negatively charged, so these particles will move towards the electrode and there they will lose their negative charge. They will lose their negative charge. Once the negative charge is removed, what will happen? There are so many other arsenious sulfide, those will combine or those will get associated and they will form a precipitate on the electrode. Okay, so this is how do we prove that colloidal particles are carrying certain charge. So the name of the experiment is electrophoresis. Okay, then what is exactly the meaning of electrophoresis? See, the movement of colloidal particles under electric field is called as electrophoresis. So 1 marks if they ask what is electrophoresis. Electrophoresis is nothing but the movement of the charged colloidal particles under electric field or under applied electric field, whatever you can write. So that is the movement of colloidal particles is called as electrophoresis. Now another part is here. See, if the movement of the soul particles is prevented by suitable method, then dispersion medium particles move towards the electrodes. This is called as electroosmosis. Okay, see, we know that in a colloidal solution there are 2 parts. Which are those? In a colloidal solutions there are 2 parts. One is the dispersion phase and another one is a dispersion medium. There are 2 parts. Okay, dispersed phase particles, only by acquiring charge they will become colloids, isn't it? Colloidal particles. Now if I if I remove or if I can make these colloidal particles neutral by adding electrolyte, there are so many methods to remove the charge from the colloidal particles that we shall discuss later. Okay, so once I remove the charge present on the colloidal particles and then I do the electrophoresis, then what will happen? The dispersion medium particles have to move towards the oppositely charged electrode. That process or that phenomenon is called as electroosmosis. Okay, so very important for 1 marks or for 2 marks. Okay, so now we will move on to the next property of the colloids, that is we will discuss about the precipitation property. Precipitation, or even we call it as coagulation of the colloids. Now we will move on to that. Okay students, now we will study the fifth property, that is precipitation, or another word is a coagulation. Okay, so we know that the stability of the colloids is due to the existence of charge. This is what now previously studied, isn't it? So colloidal particles stability depends on the charge. If they carry charge, then only they are stable. If they don't carry any charge, then they will get precipitated. That's what we have seen in the electrophoresis, isn't it? When we pass the electric current through the colloidal solutions, okay, so colloidal particles will be carrying certain charge. So when we pass electricity, these colloidal particles will move towards the oppositely charged electrode, and at electrode they will get discharged. When they lose their charge, what will happen? When they lose their charge, that is, if the charge is removed, then they become neutral. Then they become neutral. When neutral colloidal particles come close to one another, they will get aggregated or associated and get precipitated due to gravity. Okay, ಈಗ for example ಏನಂತಂದ್ರೆ ನೀವು ಒಂದು ಸ್ಲೈಟ್ಲಿ ಮಡಿ ವಾಟರ್ ತಗೋರಿ, ಸ್ವಲ್ಪ ಕೆಸರಿನ ನೀರು ತಗೊಳ್ರಿ, ಆ್ಯಂಡ್ ಯು ಅಲೌ ದ ವಾಟರ್ ಟು ಸ್ಟ್ಯಾಂಡ್ ಫಾರ್ ಸಮ್ ಟೈಮ್. ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್? ಓಕೆ, ಸೊ ಆಫ್ಟರ್ 1 hour 2 hour ಏನಾಗ್ತಾವ ಅಂದ್ರೆ, ಸೊ ಸ್ಲೋಲಿ ದ ಮಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗ್ತಾವ ಕೆಳಗಡೆ ಸೆಟಲ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾವ. ಯಾಕೆ ಆ ರೀತಿ ಆಗ್ತದೆ? ಬಿಕಾಸ್ ಗ್ರಾವಿಟಿ ವಿಲ್ ಪುಲ್ ದ ಪಾರ್ಟಿಕಲ್ಸ್ ಸ್ಲೋಲಿ ಡೌನ್ವರ್ಡ್ಸ್ and slowly the dirt particles will settle down and you will get the water. Only very smaller particles which are in the range of colloidal particles or true solution particles, only they will be remaining the water, but which are which will come in a suspension part, they will slowly settle down because gravity will pull them down. Okay, so now the process of settling down the colloidal particles is called as coagulation or precipitation. Simple, you can remember this word, but you should also know the alternative word for precipitation is coagulation. Okay, so now we know that when the charge on the colloidal particles is removed, then the colloidal particles will get precipitated. Okay, so this we now know. Okay, now there are different methods for precipitation or coagulation of the colloidal particles. We follow different methods. Okay, in that the first method is electrophoresis. So this we have already studied what happens in electrophoresis. Okay, now the second method is by boiling. So by boiling, what will happen? See, now we already know that the colloidal particles possess some charge, or the charge present on the colloidal particles is due to the dispersed phase particle. Say this is AgI. Now this is a dispersed phase particle is carrying certain charge because this one has adsorbed, isn't it? This one has adsorbed certain charge on it. It may be positive or it may be negative, isn't it? Adsorption. And we know that we have also studied adsorption in this chapter only. So for one of the factor affecting the adsorption is temperature. So when we increase the temperature, what will happen? Desorption will start. So when we boil, these adsorbed charges will be desorbed. This is one thing will happen. Second thing will what will happen? When we boil the colloidal solution, these colloidal particles kinetic energy will increase. When the kinetic energy will increase, they will collide with another colloidal particles, or they might collide with the dispersion medium particles. Then in that collision, what will happen? The charge will be removed. Okay, so by boiling also we can remove the charge present on the colloidal particles. Next, third one is by continuous dialysis. Now we have studied dialysis also. What will happen in dialysis? Dialysis is one of the methods for the purification of colloidal particles. Now we have defined what is the meaning of Purification of colloids, we know that whenever the colloidal particles or whenever the colloidal solution is formed, there will be some amount of excess amount of electrolytes are present. So the removal of that excess amount to the required amount of electrolyte is called as purification of colloids. So in that purification, dialysis is one method. So in dialysis, what will happen? We will take the colloidal solution in one animal membrane, and that bag is immersed in a tank wherein the water will be continuously flowing. So only electrolytes will be will be passing through the that animal membrane, and only the colloidal solution will be remaining in the that membrane or the bag, okay, with the required amount of electrolyte. If we do continuous electrolysis, then what will happen? If we do continuous dialysis, then what will happen? On continuous dialysis, what will happen means whatever the required amount of electrolyte is there, that also will be removed. So we have to do dialysis, but not too many times, or we don't have to do continuously dialysis. If we do that, then again colloidal particles will be losing their charge and they will get precipitated. Okay, so these are the three methods. Then the fourth one is the name is saying the mutual coagulation or mutual precipitation. Now you know the meaning of mutual, okay, give and take. Okay, so in mutual coagulation or precipitation, what will happen? See, when two oppositely charged colloidal sols or colloidal solutions are mixed in equal volume, then both the sols get mutually coagulated. It's obvious, isn't it? So when two oppositely charged colloidal particles are mixed in equal amount, then what will happen? A positive charge, negative charge. Now AgI is here, then same AgI, this may carry negative charge, isn't it? Okay, so when I mix silver iodide of positive charge and silver iodide of negative charge in equal volume, then these two will, this is positive, this is negative charge, both of them will attract together, and when in attraction, positive, these adsorbed ions, they will get they will get combined, and again the colloidal particles will lose their charge, and what will happen? These two silver iodides will be combining or get associated, and they will get precipitated. So this method is called as mutual coagulation or precipitation. Here one example we have taken, ferric hydroxide, which is positively charged, when it is mixed with arsenious sulfide, which is negatively charged, when they are mixed together, both of them will get precipitated. Okay, even ferric hydroxide will get precipitated and arsenious sulfide will be precipitated. Why? Because the charge of them will be removed. Okay, so these are the four methods. There is one more method called as addition of electrolytes. So that we shall see now, the fifth method. Okay students, now we will study the fifth property, that is precipitation, or another word is a coagulation. Okay, so we know that the stability of the colloids is due to the existence of charge. This is what now previously studied, isn't it? So colloidal particles stability depends on the charge. If they carry charge, then only they are stable. If they don't carry any charge, then they will get precipitated. That's what we have seen in the electrophoresis, isn't it? When we pass the electric current through the colloidal solutions, okay, so colloidal particles will be carrying certain charge. So when we pass electricity, these colloidal particles will move towards the oppositely charged electrode, and at electrode they will get discharged. When they lose their charge, what will happen? When they lose their charge, that is, if the charge is removed, then they become neutral. When neutral colloidal particles come close to one another, they will get aggregated or associated and get precipitated due to gravity. Okay, for example, ಏನಂತಂದ್ರೆ ನೀವು ಒಂದು ಸ್ಲೈಟ್ಲಿ ಮಡ್ಡಿ ವಾಟರ್ ತಗೋರಿ, ಸ್ವಲ್ಪ ಕೆಸರಿನ ನೀರು ತಗೊಳ್ರಿ, and you allow the water to stand for some time. What will happen? Okay, so after 1 hour 2 hour ಏನಾಗ್ತಾವ ಅಂದ್ರೆ so slowly the mud particles ಏನಾಗ್ತಾವ ಕೆಳಗಡೆ ಸೆಟಲ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾವ. ಯಾಕೆ ಆ ರೀತಿ ಆಗ್ತದೆ? ಬಿಕಾಸ್ ಗ್ರಾವಿಟಿ ವಿಲ್ pull the particles slowly downwards and slowly the dirt particles will settle down and you will get the water. Only very smaller particles which are in the range of colloidal particles or true solution particles, only they will be remaining the water, but which are which will come in a suspension part, they will slowly settle down because gravity will pull them down. Okay, so now the process of settling down the colloidal particles is called as coagulation or precipitation. Simple, you can remember this word, but you should also know the alternative word for precipitation is coagulation. Okay, so now we know that when the charge on the colloidal particles is removed, then the colloidal particles will get precipitated. Okay, so this we now know. Okay, now there are different methods for precipitation or coagulation of the colloidal particles. We follow different methods. Okay, in that the first method is electrophoresis. So this we have already studied what happens in electrophoresis. Okay, now the second method is by boiling. So by boiling, what will happen? See, now we already know that the colloidal particles possess some charge, or the charge present on the colloidal particles is due to the dispersed phase particle. Say this is AgI. Now this is a dispersed phase particle is carrying certain charge because this one has adsorbed, isn't it? This one has adsorbed certain charge on it. It may be positive or it may be negative, isn't it? Adsorption. And we know that we have also studied adsorption in this chapter only. So for one of the factor affecting the adsorption is temperature. So when we increase the temperature, what will happen? Desorption will start. So when we boil, these adsorbed charges will be desorbed. This is one thing will happen. Second thing will what will happen? When we boil the colloidal solution, these colloidal particles kinetic energy will increase. When the kinetic energy will increase, they will collide with another colloidal particles, or they might collide with the dispersion medium particles. Then in that collision, what will happen? The charge will be removed. Okay, so by boiling also we can remove the charge present on the colloidal particles. Next, third one is by continuous dialysis. Now we have studied dialysis also. What will happen in dialysis? Dialysis is one of the methods for the purification of colloidal particles. Now we have defined what is the meaning of purification of colloids. We know that whenever the colloidal particles or whenever the colloidal solution is formed, there will be some amount of excess amount of electrolytes are present. So the removal of that excess amount to the required amount of electrolyte is called as purification of colloids. So in that purification, dialysis is one method. So in dialysis, what will happen? We will take the colloidal solution in one animal membrane, and that bag is immersed in a tank wherein the water will be continuously flowing. So only electrolytes will be will be passing through the that animal membrane, and only the colloidal solution will be remaining in the that membrane or the bag, okay, with the required amount of electrolyte. If we do continuous electrolysis, then what will happen? If we do continuous dialysis, then what will happen? On continuous dialysis, what will happen means whatever the required amount of electrolyte is there, that also will be removed. So we have to do dialysis, but not too many times, or we don't have to do continuously dialysis. If we do that, then again colloidal particles will be losing their charge and they will get precipitated. Okay, so these are the three methods. Then the fourth one is the name is saying the mutual coagulation or mutual precipitation. Now you know the meaning of mutual. Okay, give and take. Okay, so in mutual coagulation or precipitation, what will happen? See, when two oppositely charged colloidal sols or colloidal solutions are mixed in equal volume, then both the sols get mutually coagulated. It's obvious, isn't it? So when two oppositely charged colloidal particles are mixed in equal amount, then what will happen? Positive charge, negative charge. Now AgI is here, then same AgI, this may carry negative charge, isn't it? Okay, so when these two, when I mix silver iodide of positive charge and silver iodide of negative charge in equal volume, then these two will, I mean this is positive, this is negative charge, both of them will attract together, and when in attraction positive, these adsorbed ions, they will get they will get combined, and again the colloidal particles will lose their charge, and what will happen, these two silver iodides will be combining or get associated, and they will get precipitated. So this method is called as mutual coagulation or precipitation. Here one example we have taken, ferric hydroxide, which is positively charged, when it is mixed with arsenious sulfide, which is negatively charged, when they are mixed together, both of them will get precipitated. Okay, even ferric hydroxide will get precipitated and arsenious sulfide will be precipitated. Why? Because the charge of them will be removed. Okay, so these are the four methods. There is one more method called as addition of electrolytes, so that we shall see now, the fifth method. Now we will study the fifth method for the precipitation of electrolyte is by addition of excess of electrolyte. Okay, see, on adding excess of electrolyte, zeta potential will be decreased. This we have already discussed, isn't it? What is the zeta potential? Zeta potential is nothing but the potential difference between the two oppositely layer. Means, see, this is if our colloidal particle, then there will be first layer of positive charges, then there will be a second layer of negative charges. If the potential difference between these two is high, then stability of the colloidal particle will be high. Okay, but when we add excess of electrolyte, the potential difference between these two layers will decrease. It means what will happen, when the potential difference between these two layers is decreased, this positive charge, this negative charge will combine. Why they will combine, that also I will tell you. See, when you add excess amount of electrolyte, what will happen? There will be more amount of positive negative charges will be developed in the entire colloidal solution. When there is more amount of positive negative charges are available, then what will happen? This has to be balanced. The positive and negative charge has to be balanced. Therefore, when there is more amount of positive and negative charges, these two layers will get dispersed, or they will get diffused. Means these positive charges will combine, just like this one, what chemical equilibrium chapter you have studied. So when excess of electrolyte is added, there has to be some balance has to be maintained. Therefore these two will start combining, and when these two will start combining, this will lose its charge. Okay, so on addition of excess of electrolyte, zeta potential of colloids is decreases and sole particles get precipitated. Okay, now next, the ion which is responsible for the coagulation or the precipitation of the sole particle is called as a coagulating ion, and its valency is called as coagulating power. Okay, now if your colloidal particles are negatively charged, and then positively charged ions will remove their charges. Okay, so if higher is the charge of these electrolytes, then more will be the coagulating power. Okay, I hope you can understand. Now aluminum's valency or oxidation state is higher, so this one, now suppose let us say AgI I have, and this is negatively charged, so single negative charge, but here +3 charge is there, so more is the valency and single charge is there, so this one aluminum can precipitate 3 of the sole particles. Okay, then comes magnesium has 2 positive charge, then this one can precipitate 2 of the negatively charged sole particles, and sodium is 1, so it will precipitate only 1. So higher is the oxidation state, more is its coagulating power. I hope you can understand what is the meaning of coagulating power. Coagulating power andru onde, amele precipitation power antandru onde. Okay, then if the sole particles athwa colloidal particles positively charged iddu antandre, then negatively charged electrolytes will remove their charges. So here this one hexacyanoferrate is there. Now this has got -4 charge, means this single ion will coagulate or precipitate 4 of the positively charged colloidal particles. Now phosphate ion is there. Now phosphate ion has -3 charge, so this will precipitate 3 of the positively charged colloidal particle. Sulfate will do 2 and a chloride ion will do 1. So more is the oxidation power, higher will be its coagulating power or precipitation power. Okay, I hope you are understanding it. Then the second concept in this only, that is the concentration of the electrolyte required in millimoles to precipitate 1 liter of the colloidal solution is called as flocculating value. It is called as flocculating value. So it is obvious, isn't it? If for example you take this one, aluminium, okay, it is having +3 charge, okay, so it is required in less. It is required less because a single aluminium ion can precipitate 3 of the colloidal particles. So lesser concentrated aluminium solution is enough. I hope you are understanding. Same goes with this. Now this single ion can precipitate 4 of the positively charged colloidal particles, means what is the volume required? It will be less. Okay, so how much volume or how much quantity of the electrolyte is required in millimoles to precipitate how much? 1 liter of the colloidal solution is called as flocculating value. It is called as flocculating value. So we can say if less quantity or if less volume is needed, then higher is its flocculating value. I hope you can understand this. Okay, then coagulation power is inversely proportional to the flocculating value. Why? Because flocculating value is less when less quantity of the electrolyte is required to precipitate 1 liter of colloidal solution. It means what? Its coagulation power or its oxidation state will be higher. Okay, so this is the meaning, that is coagulation power is inversely proportional to the flocculating value. So in competitive examination they will confuse you by giving flocculating value, and they will ask you which is having a higher coagulation power. Okay, I hope you are understanding. They will give you flocculating value and they will ask you whose coagulation or precipitation power is more. Okay, then higher the charge, lesser will be the flocculating value. This you have to remember. Otherwise this is another formula. If 2 of the electrolytes they will give you, and they will ask you what is the coagulating power of electrolyte 1 compared to electrolyte 2. Okay, then using these two they will give you flocculating value of both the electrolytes. They will give you the flocculating value of both the electrolytes. Substitute whatever value will get. Now suppose say this will remain the same. Okay, and if suppose they have given the value something, let us say 30 divided by 15 is equal to 2, then coagulating power of 1, okay, E1 is equal to 2 times E2. Okay, so this is also very important from competitive examination point of view. Okay, so these are the different methods for precipitation of the colloidal solutions. Next we will move on to the next factor, that is coagulation of lyophobic colloids. Now let us see that. Okay, my dear students, now let us move on to the next concept, that is coagulation of lyophilic colloids, or we can say precipitation of the lyophilic colloids. Okay, now lyophilic colloids are more stable than lyophobic colloids. Why the lyophilic colloids are more stable than the lyophobic colloids? See, one thing we have to understand is all the colloids are stable, but one common reason why lyophilic and lyophobic colloids are stable, because they are carrying charge. Be it any colloid, lyophilic or lyophobic, they are carrying charge, that's why they are stable. But even then lyophilic colloids are more stable. Why? Because even though they carry charge, they are solvation, or they are solvated. So what is the meaning of solvated? See, now let me consider one colloidal particle here, and if it is negatively charged, okay, like this, if it is negatively charged, solvated means, see, water molecules will surround this like this. Why water molecules will surround? Because your colloidal particle is negatively charged and these hydrogens are partially charged, partially positive charge, isn't it? So like this, the water molecules will surround your colloidal particles. So this forms a certain type of protecting layer around the lyophilic colloids. Okay, solvated means this, the water molecules will surround your colloidal particle. And we know the definition of lyophilic colloids. What are lyophilic colloids? Lyo means liquid, philic means liquid loving. So if your liquid is water or hydrophilic, then these colloidal particles are attracted by these water molecules. So it's just like a protecting layer is formed around the lyophilic colloidal particles. Therefore, it is not easy for precipitating the lyophilic colloids. Okay. Then how do we precipitate? Simple. If we remove the protecting layer, then what will happen? We are getting our colloidal particles negatively charged or positively charged. Then when I add excess amount of electrolyte, then what will happen? That electrolyte will react with these ions and this ion charge of the colloidal particles is removed. When the charge of the colloidal particles is removed, then they will get precipitated. Simple. So first thing, how do we remove this hydrated part? How do we remove the water molecules? See, when alcohols or acetones are added, then the sole particles get dehydrated. So when we add a little amount of alcohol and acetones to the lyophilic colloids, then these water molecules get dehydrated. Then addition of small amount of electrolyte will cause the precipitation. Right, that's what we have discussed now. So this is in regarding to the lyophilic colloid. So the question is, two questions will arise: why lyophilic colloids are more stable, or in other words, why it is difficult to precipitate the lyophilic colloids. Okay, so this is our answer, and we also got to know how do we precipitate the lyophilic colloids. Okay, then moving on to the next one, that is called as protection of the lyophobic colloids. Now we know that lyophilic colloids are more stable, then lyophobic colloids are less stable. Why they are less stable? Because in lyophobic colloid, the colloidal particles are having a hatred nature towards the dispersion medium. So there is no protection layer around the lyophobic colloidal particles. Okay, then the lyophobic colloids are very easy to precipitate. Even a small amount of electrolyte is added, then they will get precipitated. Okay, then how do we protect the lyophobic colloids from precipitation? Okay, see, the precipitation of lyophobic salts is prevented by adding lyophilic colloids. This is important. So if we add lyophilic colloids to the lyophobic colloids, what will happen? These lyophilic colloids will form here if it is your lyophobic colloid, certain charges are there. And if you add lyophilic colloid onto this, again one lyophilic colloids will surround this like this, and upon this again water molecules will surround these. So now it is your lyophobic colloids are protected. Okay, so the precipitation of lyophobic colloids is prevented by adding lyophilic colloids. I hope you are understanding this. Then the process of preventing the precipitation of lyophobic colloids by electrolytes due to previous addition of lyophilic colloids is called as protection. So 1 marks question, many a times asked. What do you mean by protection of lyophobic colloids? 1 marks question, very important. So protection of lyophobic colloids means the process of preventing the precipitation of lyophobic colloids by the electrolytes due to previous addition of lyophilic colloids is called protection of lyophobic colloids. Means suppose this your lyophobic colloid has to be prevented from the precipitation by the addition of electrolytes. Means before the electrolytes are added to the lyophobic colloids, you have to add lyophilic colloid. Then even after the addition of lyophilic colloids, then if we add electrolytes, then the precipitation will not occur that easily. So previous addition means before addition of electrolytes we have added lyophilic colloids. So that is called as protection of the lyophobic colloids. Then lyophilic colloid used is called as a protecting colloid. Okay, so the colloid, I mean the lyophilic colloid that we are using for the protection of lyophobic colloids is called as protecting colloid. Let us see some example. Okay, important is a gelatin will come under this, gelatin, starch, albumin, even hemoglobin. Okay, so these are some lyophilic colloids which are used for the protection of the lyophobic colloids. Then what are lyophobic colloids? The question will come again, like the less reactive metals like your gold, silver, platinum, okay, and copper, even they will be coming under lyophobic colloids. So the precipitation of those gold, silver and other less reactive metals is prevented by addition of these lyophilic colloids. Usually we will use gelatin. Or starch is more easily available, so sometimes starch will be used. Okay, then next, protecting power of colloids is expressed in terms of gold number. Okay, so what is gold number? Means every lyophilic colloid has its own protecting power. Okay, now here I have written 4 examples. So among these 4 examples, which has the higher protecting power? It is gelatin, which is having higher protecting power. Okay, so the protecting power of each of the lyophilic colloid is expressed in terms of gold number. So again, 1 marks question. Define gold number, or what is gold number? Then what it is? See, the minimum amount of protecting colloid required in milligrams. This is important. Okay, so the minimum amount of protecting colloid required in milligrams just to prevent the precipitation of 10 ml of gold sol from 1 ml of 10% of NaCl solution. What is the meaning this? Let us understand the meaning. Suppose I have 10 ml of gold sol with me. How much? 10 ml. Okay, suppose there is one test tube like this, and I have 10 ml of gold sol with me. Okay, so I have not, imagine that I have not added any lyophilic colloid. Then even if I add 1 ml of 10%, so power of the electrode is also less, only 10%, 1 ml of 10% of NaCl solution, then gold particles present in this, they will get precipitated like this. Okay, so how much of the protecting colloid I have to add to prevent the precipitation is called as gold number. It is called as gold number. So what just like I'll repeat again, if I got a 10 ml of gold sol with me, okay, then how much amount of, or that is how many milligrams of a protecting lyophilic colloid that I have to add. Okay, lyophilic colloid. Okay, I have to add before I am adding 1 ml of 10% of NaCl solution. Okay, this is called what? Gold number. So the minimum amount of protecting colloid required in milligrams just to prevent precipitation of 10 ml of gold sol from 1 ml of 10% of NaCl solution is called as gold number. So now we can say, see, this minimum amount is required. What? The lyophilic colloid is required in minimum amount. Okay, so now gold number and protecting power are inversely proportional. They are inversely proportional. So if we are requiring minimum amount of the lyophilic colloid, then it means what? Its protecting power is more. It means its gold number is less. Okay, so gold number and protecting power are inversely proportional. Okay, so gold number means minimum amount, protecting power higher is the protecting power, then gold number will be less. Why? Because gold number means what? It is a minimum amount of the protecting colloid required. So minimum amount of the protecting colloid required, so that it's a protecting power will be high. Okay, so this is about the protection of lyophobic colloids. So remember, so 1 marks question they will be asking, what do you mean by protection of lyophobic colloids, what do you mean by protecting colloid, or most important one is what is meant by gold number. So from competitive examination point of view, this relationship is very important. They will give you the gold number, I mean they will give serially like this, they will give you serially different lyophilic colloids or different protecting colloids they will give. Different protecting colloid they will give, and they will give their gold number, and they will ask you whose protecting power is more. Then how do you identify? Lesser is the gold number, higher is the protecting power. Here one hint is what? Among all the protecting colloid, gelatin has the higher protecting power, means its gold number will be less. Okay, so now we will move on to the last phase of this chapter, that is emulsions. So now we shall see about the emulsions. Okay, my dear students, now we will study the last part of the surface chemistry chapter, that is emulsions. Okay, so now what is meant by emulsions? See, emulsions are the colloids in which both the dispersion medium, DM refers to dispersion medium and DP refers to dispersed phase. So both the dispersion medium and dispersed phase are liquids. Okay, then emulsions are generally prepared by two immiscible or partially miscible liquids by mixing them and then vigorously shaking them. But when allowed to stand, they get separated. For example, oil and water. Means, see, usually emulsions are two immiscible liquids. Emulsions are two immiscible liquids. When they are mixed together, just like oil and water, they will get separated. Right, oil will be on the top and water will be at the bottom. Okay, then if I shake this oil and water for several minutes, like continuously shaking, then you will see some froth will be developed in between the junction. There will be some froth will be developed. Okay, say this is oil and water, the upper part is oil and then the lower bottom part is water. When vigorously shake, there will be some froth developed here. There will be some froth developed here. Means we can say that emulsion is developed here. Only that part is emulsion now. Okay, then after, if I allow it to stand for some times, so if I don't shake it and I'll just simply keep it, then after some time what will happen? This froth will be disappearing, means again oil and water are separated. Okay, then it is giving us a hint that, see, these two liquids are not miscible, means there is some surfacial this interfacial tensions are there. Okay, interfacial tensions mean density. There is a difference in the density between oil and water. So now we require certain substance which can reduce this tension between these two liquids. Okay, so the substance required which will stabilize the tension between these two liquids is called as stabilizing agent. Okay, or we can call it as emulsifying agent. So the substance used for stabilizing the emulsions is called as emulsifying agent. What it is called as? Emulsifying agents. When we were studying the cleansing action of soaps, okay, we discussed that whenever there is a oil droplet present on the our cloths, okay, then simply by using water the oil droplets cannot be removed or the grease particles cannot be removed simply. Then what we will make use of? We will make use of soaps and detergents. There the soaps and detergents will act as the emulsifying agents. Means what will happen? The detergents part will be like this, the hydrophobic part will be inside the oil and the hydrophilic part will be inside the water. So when we shake it, what will happen? These hydrophilic parts will interact with the water and they will come out with little bit part of the oil in them. Isn't this, we have studied it, isn't it? The same way the emulsifying agent will work out. Okay, it means simply it will reduce the tension between the two immiscible liquids. Okay, for example, the best example is, see, milk is a natural emulsion. Milk is a natural emulsion in which casein acts as the emulsifying agent. So many a times 1 marks tricky question is asked, what is the emulsifying agent present in milk? It is casein. It is the casein. Then you may ask, there is no separation of the, milk is made up of what then? Say milk is made up of two substances. One is water and liquid fat. Okay, so this you can clearly see. Take milk and you add some amount of citric acid. Okay, when you squeeze the lemon into the milk, what will happen, and boil it, what will happen? You will see that the fat is separated and the water is separated. That you have seen, isn't it? So those agents which will separate the two immiscible liquids, those are called as de-emulsifying agent, or the process is called as de-emulsification. Sometimes this also has been asked. What is emulsification? Emulsification means when two miscible liquids are made emulsion by using emulsifying agent. Then what is a de-emulsification? De-emulsification means separation of the two liquids present in a emulsion by use of a de-emulsifying agent. Okay, so now casein is a emulsifying agent which is holding the fat and the water. Okay, so when that casein is destroyed, then the fat will be getting separated and water will be getting separated. I hope this you can understand, and this also you can understand. You have an idea now, okay, how the emulsifying agent will work. This is the idea, and now we know what is emulsifying agent, what is emulsification, what is a de-emulsification, and what are de-emulsifying agents. Okay, then moving on to the next topic, that is the types of emulsion. See, there are two types of emulsions are there. First one, oil in water, we indicated by O bar or O/W we can indicate. Okay, then what are oil in water emulsions? In this oil is acting as a dispersed phase and water is going to act as the dispersion medium. What are the examples for oil in water? Okay, milk is example, then vanishing cream, some of the creams that we apply to remove some of the dirts. Okay, so we call them as vanishing creams. So what is meant by oil in water means here oil is going to act as a dispersed phase, and simply the name itself is indicating oil in water means oil is present in oil means it's kind of a fat only. So in milk what we can see, fat is present in water. So oil in water means oil is going to act as a dispersed phase and water is going to act as the dispersion medium. So milk is example for the oil in water type of emulsions. Then the next one is opposite to this, that is water in oil. So now water is present in less quantity, oil is present in more quantity, means oil is the dispersion medium, then water is the dispersed phase. So we indicate it by like this. Okay, oil in water is O/W, then water in oil is W/O. Okay, then what are the example for water in oil is your butter and cold creams. Okay, then now how do we identify which type of emulsion we have? Okay, whether we have oil in water or water in oil, how do we identify? So one of the test is a dilution test. Okay, see what we have to do is whatever emulsion we have with us, go on adding water. On adding water, if the emulsion gets diluted, just take this oil in water, milk you add the water to this milk, what will happen? It gets diluted, but there is no separation of the fat and water, isn't it? Is just on addition of water it gets diluted. It means what? Dispersion medium is water there. So more amount of dispersion you add, nothing is going to happen. But on addition of water, if they are getting separated, means it is it means water in oil. I hope you are understanding it. So identification of emulsions is also important. So these are the important concepts that are coming under surface chemistry chapter. Now there is one more concept under this will come, that is called as colloids around us. So that I will discuss now. What is meant by colloids around us? See, we are surrounded by so many colloids around us. See, for example, the sky appears to be blue. Why it appears to be blue? Because we have studied in Tyndall effect. And in Tyndall effect, we said that the colloidal particles have the ability to scatter the light. Okay, so in the open atmosphere, there are some dust particles are present, okay, which will scatter the sunlight, and when the sunlight is scattered, the minimum wavelength is blue color. I have said it, for scattering of that light, we require the diameter of the colloidal particles have to be in the, it has not to be too small. Okay, so the molecules, when they scatter the light, we see it as blue. Okay, so the sky appears blue because there are some colloidal dust particles are present in the atmosphere, in the upper atmosphere, which will scatter the light, and that's why the sky appears to be blue. The same thing goes with the sea water. Now sea water, sometimes it appears to be greenish, sometimes it appears to be bluish. Okay, so again the same reason, in sea also there are so many colloidal particles are present, and these colloidal particles again they will scatter the light, and whatever the scattering of the light takes place and whatever the wavelength is coming out in the visible region, that we can see, then that is the color of your sea. Okay, so these are the, these are two examples, that is sky appears to be blue and the color of the sea appears to be blue or slightly greenish, is because of the presence of colloidal particle, and these colloidal particles are scattering the light. Along with this, see, we see so many colored food items around us. So whatever the coloring agents that we are adding to the food material, even they are also colloids. And our textiles, our in textile industry, or the cloths that we wear, they are also colored. So the dyeing agents, different coloring agents that we use, we call it as dyeing agents. So those dyeing agents are also colloidal in nature. And the most important thing is the blood that flows in our body, that is also colloidal. Okay, so this is about the colloids around us. Okay, so now we have completed the surface chemistry chapter, and I have discussed in whichever part 1 marks and 2 marks question will come. So in this emulsion, so 1 marks question usually will be asking is 1 marks is this, that is what give example for the emulsifying agent, or what is the emulsifying agent present in the milk. This they ask, or definition they might ask, or they will directly ask you give example for oil in water, or what are oil in water emulsions, like this. So from this emulsion part you can expect 1 marks questions, not the 2 marks questions. If 2 marks question come, then consider yourself very lucky, because very easy to understand and very easy to represent also. Okay, so we have completed the surface chemistry, students. So in the next session we shall meet with the new chapter.